Hi, a warm welcome to you. In this video, we'll try to understand how to find out the trigonometric ratios of compound angles. What exactly we mean by that is, we know that the value of sine 30 degrees is equal to 1 by 2. Similarly, we know that the value of sine 45 degrees is equal to 1 by root 2. But suppose we want to find out the value of sine 75 degrees. We know that 75 is nothing but equal to 30 plus 45. So, if there is a formula which I can apply saying that sine 75 is nothing but equal to sine of 30 plus 45, and I can use sine or cos of 30 or sine of cos of 45 and able to write them, then we should be able to find out the value of sine 75. So we know the value of sine 30, sine 45, but knowing the value of sine 75 with current knowledge whatever we have is not possible. So what we are trying to do in this video is we are trying to understand that how the trigonometric ratios, that means sine, cos, tan, cosecant, secant and cot of compound angles, that means sum of two angles or difference of two angles, is related to the individual angles. What I mean by that is that suppose you have two angles A comma B, the compound angle of that is A plus B, or it can be A minus B, sum or difference. So suppose let us say that A comma B and the compound angle is A plus B. Now how cos of A plus B is related to cos A cos B or sin A sin B. Similarly, how sin of A plus B is related to sin A sin B or cos A cos B. That is what we want to understand, so that practically we want to find out the values of 75 or in the similar way 15 degrees. Now with the current knowledge we cannot find the value of sin 75 or sin 15, but we should be able to do that by knowing this particular formula. To derive the formula, what is the formula for cos of, we will first try cos of A plus B, then from there onwards we can leverage the same formula and we can get remaining all compound trigonometric ratios, that means sine, cosecant, secant, tan and cot of A plus B or A minus B. We will prove this. Cos of A plus B is equal to cos A cos B minus sin A sin B. This is what we are going to prove now. To do that, what I will do is I will just go ahead and try to, we know that we want to prove this. That means first I should have a point A. I will have the point with the coordinates cos A sin A only if there is this angle is equal to A and these coordinates are nothing but equal to cos A comma sin A. So we got A. Okay. Now let us see what else I need. I need B because I want to go for A plus B. So from here I will take B and I will draw another line. I will try to draw another line, and this angle is nothing but equal to B. So angle from origin to here in anti-clockwise direction is A and this angle is B. Now what is this total angle from here? A plus B. So what this becomes? This becomes cos of A plus B sin of A plus B. I hope you are with me. We are just only using the fundamentals what we know, nothing much. Sin of A plus B. Okay. Now what I have done is, from origin I have drawn a line at angle A in positive direction with x-axis, in anti-clockwise direction. I know the point which touches this unit circle, the radius of this circle is 1. That means this distance is radius equal to 1. So these coordinates are cos A sin A. From there I have taken another angle B, so that the total angle to this line, let me say, let us name this. I will just put some name here. Let me say this name as P. Okay, right, and I'll put this name as Q. Okay, right. Let's come back. Now the angle to P is A and the angle to Q is nothing but, suppose let us say that this is equal to X. Oops. Suppose I say this is equal to X. If I say X, then the angle XOP equal to A and the angle XOQ equal to A plus B. I think we had enough discussion on that. Now what I will do now, I will take the same angle B. You can see that A is between 0 and pi by 2 and A plus B is less than pi. This case we have taken. You check for any case, you can actually find it out very easily. So I will try to put the same angle here, draw the same angle in reverse direction, this, so this much. So what I will do, I will put here or let me just use the same color so that there is no confusion. I will use the same color. Okay, so this angle B, I am trying to find out that angle approximately how much it will be. Okay, so that will be something like this. So this angle is B. So what we have done, we have taken angle A, we found the coordinates, then we went to B in the positive direction, anti-clockwise direction. We found cos A plus B, sin A plus B. Now from origin we are coming down. So what will be these coordinates? You are right. These coordinates will be cos of minus B, sin of minus B. These coordinates will be cos of minus B comma sin of minus B. Okay, now we are done. Now you can check that. Let's try to find some congruency here. Why? Because now I want to find out the relation between cos A plus B sin A plus B and cos A cos B sin A sin B, right? That is the relation I want to find out. I want to prove that that is nothing but equal to this. For that I need to find out some congruency. So I know that this angle is A plus B from here. That means triangle QOX. If I join Q and X, what it will become? If I join Q and X, I will try. If I join Q in triangle, let me note it down. This is a triangle QOX. You know this total angle is equal to A plus B, and these two sides are nothing but radius of 1. That means this is nothing but two sides and the included angle is equal. Two included angle is A plus B. Now let us take this triangle PO and oh, I don't have a name for this. Let me put some name. I will say this name is equal to Y. Okay. So you look at this POY, the angle is again A plus B. Even though we are going in the negative direction, magnitude wise, the angle is nothing but equal to A plus B. And also here also you have the radius is 1 comma 1. That means you have two similar triangles. Now let me put down this also. Now you can see. Now let me write it down. In triangles, first triangle is QOX. Okay, or we will start with okay, QOX, comma, what is the other triangle? One triangle is QOX, which is making angle of A plus B and both are radius are equal to 1. Another triangle is POY. POY. You can check actually. QO equal to PO because radius equal to 1, and the angle X is and OX equal to OY. OX is nothing but equal to OY because radius. So we know that these two triangles are similar because the angle QOX equal to angle POY in these triangles. Angle QOX is equal to angle POY is equal to A plus B. You know that. And also we know QO is equal to PO, that is nothing but equal to 1 because it's a unit radius. You can see that the coordinate of this is 1 comma 0. That means x axis is distance is 0. Similarly it is 1. That means the radius is 1. That's what? Okay, right. And what else we know? We know that OX is equal to OY. That is very simple, right? OX is equal to OY. That is also equal to 1. So we know that these two triangles are congruent now because we know that the two angles are equal and the sides which are including this angle are also equal in both the triangles. That means I know that these two triangles are congruent to each other. Therefore, triangle QOX is congruent to triangle POY. Now, if I know that, then I can say directly QX is equal to PY. QX is equal to PY. How we know that? We know that because it is nothing but CPCT by corresponding parts of congruent triangles, because these two are congruent triangles. When two triangles are congruent, all the sides, corresponding sides should be equal, corresponding angles also should be equal. So QX should be equal to PY. But I know the coordinates of QX and PY. This is getting interesting. Now I know the coordinates of QX and PY. Now I know the distance between 2 points. I can apply that logic and I see I can find out any relation between them. So we'll take it forward here. In the next step, I will change the color so that we go ahead with the main logic. So we say QX equal to PY or QX square is equal to PY square. It's reasonable, right? When QX equal to PY, QX square equal to PY square. But QX square is nothing but the distance between this. What is that? That is nothing but 1 minus cos of A plus B. What is the formula we are using? x1, y1, x2, y2. The distance between 2 points is square root of x2 minus x1 whole square plus y2 minus y1 whole square. Now anyway I am squaring this, so this becomes directly x2 minus x1 whole square, x2 minus x1 whole square plus y2 minus y1 whole square. That is nothing but equal to 0 minus sine of, if you are confused, there is a, this is always cos comma sine, cos comma sine, cos comma sine. Yeah, I hope it's okay. Minus of sine A plus B whole square. x2 minus x1 whole square plus y2 minus y1 whole square. This is nothing but equal to what? Py whole square. But what is Py? P is cos A sin A coordinates and y is cos minus B sin minus B coordinates. So what is Py square? This is nothing but equal to Py square, Py whole square. Py whole square is cos A minus of cos A minus of cos minus B whole square x2 minus x1 square plus y2 minus y1 whole square, that is sin A minus of sin minus B whole square. Okay, right. Now we'll try to expand this here. if we try to expand this, what we will get? Let us see what we are going to get. I'll expand this term. This is my LHS, this is my right HS. Let me try to leverage this space and finish it off. So when I square this, what happens now? This becomes 1 plus cos square of A plus B. This is nothing but A minus B whole square, that is A square minus 2AB plus B square, that is minus 2 into 2 into cos of A plus B. I don't need this, I can say directly minus 2 cos A plus B plus sine square A plus B, that is equal to, let's take the RHS now. Let us see what I will get on the RHS side. RHS side is this one. So this becomes cos square A. Cos minus B is cos B only. So that is nothing but cos square B minus 2 cos A cos B I'll see if I can extend a little bit. Okay, plus sine square A plus sine square B minus of 2 sine A sine of sine B. That means it becomes plus, correct? It becomes 2 sine A into sine of minus B, that is minus sine A sine B, and there is one minus, so that is minus of minus. This becomes 2 sine A sine B. Okay, now let us simplify this here. This plus this is equal to 1. So this becomes 2 minus 2 cos of A plus B is equal to, if I go in this direction, cos square A plus sine square A is 1. Cos square B plus sine square B is 1. That means it becomes again 2 minus of 2 cos A cos B plus 2 sin A sin B. Now you can cancel this 2 here, you can cancel minus here, then you can cancel 2 here, and what you will be getting is cos A plus B equal to, when you take minus out, 2 minus of 2 cos, first I will cancel 2, then I will have minus of 2 cos A plus B equal to minus, if I take it common, what I will be getting is cos A plus B is equal to cos A cos B minus sin A sin B. So there are 1 or 2 steps in between, you can extend it here, due to space I haven't done, but let me explain that. See, this is nothing but equal to 2 minus of 2 into cos A plus B equal to 2 minus of 2 cos A cos B plus 2 sin A sin B. Now what I will do first is, I will take this 2 on both sides, cancel it out. I will have a minus 2 cos A plus B equal to minus 2 into cos A cos B minus sin A sin B. Minus 2, if I take it out, I will get cos A plus B equal to cos A cos B minus sin A sin B. I hope you should be able to do that. So so you can see now I know cos A plus B equal to cos A cos B minus sin A sin B. In the next video, we will see, based on this, how we can find out sin A plus B, tan A plus B, tan A minus B, cot A minus B, whatever you want with respect to the compound angles. Because we found one formula, we should be able to leverage that formula and we should be able to get it back. Now let me just summarize what we have done in this. We want to find out, suppose sin 75 or cos 75. Till now we know sin 30, sin 45, but we don't know sin 75. And also we know 30 plus 45 equal to 75. So if I can have a relation between sin 75 which is nothing but combination of sin 30, cos 30, sin 45, cos 45 in one particular formula, I should be able to get the value of sin 75. So we are talking about compound angles. Till now we are talking about sin A, cos A, sin B, cos B. Now what is the relation between sin of A plus B and the individual angles sin A, cos A, sin B, cos B? To do that, what we have done is we have taken a unit radius circle. We have taken a unit circle and we have first found we have pointed a point P which is making an angle A, and the coordinates are cos A sin A. From the point, from the line OP, I have drawn another line making an angle B in the counterclockwise direction, that is nothing but positive direction. Then I got OQ. Now I know the coordinates of OP is cos A sin A, and the coordinates of OQ is cos A plus B comma sin A plus B. Now what I have done, now I want to prove relation between cos A plus B, cos A sin A and cos B sin B, right? So I found cos A sin A, from there I came here, but I want B. So what I have done, from origin I went in the reverse direction and I took an angle of B, negative direction, but you can see magnitude wise the angle is same, A plus B here and also A plus B here. Now the coordinates of that point y is nothing but cos of minus b, sin of minus b because we are going in the negative direction. Now you can see that the triangles QOX and POY are congruent. They are congruent because their their sides are nothing but equal to corresponding sides are nothing but equal to radius 1, and the included angle between those two sides is nothing but equal to A plus B. Now using corresponding parts of congruent triangles, I know that the distance between PY and QX equal to 0, which I am really interested because I have here constant. Here I have cos A plus B, sin A plus B. Here I have cos A, cos B. So what I have done, I have leveraged the formula of distance between 2 points. By corresponding parts, I know Qx equal to Py. Now we have squared it. We have said Qx whole square equal to Py whole square. Then we know that is nothing but equal to 1 minus cos A plus B whole square plus 0 minus of sin A plus B whole square is nothing but equal to cos A minus cos minus B whole square plus sin A minus sin minus B whole square. This is nothing but just applying the formula x2 minus x1 whole square plus y2 minus y1 whole square, where x1, y1, x2, y2 are 2 points. So just we have leveraged that, nothing great in it. Now after that we have simplified it. We have applied the identity cos square A plus sin square A equal to 1, which when we simplified, we found that 2 minus 2 of cos A plus B equal to 2 minus 2 cos A cos B plus 2 sin A sin B. Now you take out 2 in both LHS and RHS and take out the minus from LHS and RHS, then divide by 2, you will be getting cos of A plus B equal to cos A cos B minus sin A sin B. Now once we know this, in the next video we will see how we can leverage this and find out cos of A minus B, sin of A minus B, tan of A plus B, tan of A minus B, and also we will see how we can find out the values of tan 75, cot 15 or tan 135, secant 75, whatever the values we want. We will use compound angles and we'll find out those angles. So see you in the next video where we will expand this, whatever we have learned in this session. Thanks for visiting. Bye for now.